Okay, in this presentation we are going to look at Introduction to Probability exercises. Okay, so we'll be covering some of the same ground as I have done in similar videos to this. Okay, you'll probably see that in A and B, the exercises A and B I mean. But there are some new things here, or some that are specific to this video, and they come up really in parts C and D, and they deal with the complements of events, which is the probability of something not happening. Okay. Anyway, let's just read the question. So we have probability of A equals 0.45 and the probability of B equals 0.6. And let probability of A union B equals 0.75. Okay. So we got a couple of exercises here. Really, it's a bit confusing that I've given them, indexed them by letters. Let's call them 1, 2, 3, 4. The first two, the exercise A and B, calculate the probability of A intersection B and state are A and B independent. Okay, and then C and D, this deals with the complement events of event A and event B. Okay, so this is the probability of event A not happening and the probability of event B not happening. Okay, and then the complement, or the probability of the complement of A union the complement of B. Okay. So we're given these pieces of information. The probability of event A is 0.45, probability of event B is 0.6, and the probability of A union B equals 0.75. Okay, so that's A happening, B happening, or both. Okay, so exercise A, as in the first exercise, calculate the probability of A intersection B. Okay, so what we're going to do here is use the formula for the union of two events. So how you would usually state this is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. Okay, but what we're going to do is rearrange this algebraically so that we can have an expression in terms of the probability of A intersection B. So it's essentially move them round, swap one from one side to the other. So we have the probability of A intersection B equals the probability of A plus the probability of B minus the probability of A union B. Okay, so that is the probability of A intersection B equals 0.45 plus 0.6 minus 0.75, and that gives us an answer of 0.3. So the probability of A intersection B equals 0.3. Are A and B independent? Are two events A and B are independent if A intersection B is equal to the probability of A times the probability of B. Okay, so the probability of A times the probability of B is 0.45 times 0.6, and that is equal to 0.27. But we know that the probability of A intersection B from the last question is 0.3, and that is not equal to 0.27, so the events A and B are not independent. That's all we have to say. Not independent. That's enough of an answer there, as we will need. Let's move on to the next question. So exercise C, and this is to do with the complements of A and B. This is the probability of A not happening. That's the probability of the complement of A. And likewise, the probability of event B not happening, probability of the complement of B. Essentially what we do is just subtract one from the other. Essentially, they must add up to 1. It's one of the axioms of probability, essentially. So the probability of the complement of A is 1 minus the probability of A, which is 1 minus 0.45, and that's equal to 0.55. Likewise, the probability of the complement of B is 1 minus the probability of B. That is equal to 1 minus 0.6, which is 0.4. So there we have it there, 0.55 and 0.4. That is the complement of A and the complement of B. And finally, let's look at exercise D, which concerns De Morgan's laws. So let's just read the question. Calculate the probability of the complement of A union the complement of B. So there are two De Morgan's laws. One is essentially the mirror of the other, and they both have a very similar structure. But I'm only going to address this one for this particular video. The complement of A union the complement of B. The probability of that is calculated as follows. 1 minus the probability of A intersection B. So we actually found A intersection B in part A earlier on, which the answer was 0.3. So the answer we're looking for is 1 minus 0.3, which is 0.7, and that wraps it up. Okay. A handy way to actually get the hang of De Morgan's laws is actually sort of draw it out, Venn diagrams and so on. Just actually draw it out there and get a sense of it like that. Okay, we'll leave it there.